Are you ready for some more? Probably not, but we gotta go through it. It's part of pre-calculus. All right. So it will continue. Trig identities. So one of the next tricks in your bag that you need to be able to use to solve these trig identities is to go ahead and put things, your trig functions, in terms of sine and cosine. Reduce them to that. So I go up there and I take a look at my reciprocal ones. Again, you should have your sheet right next to you. And so when I say, hey, look at your reciprocal ones, cosecant, again, you should start getting a pattern here is 1 over sine of x minus cosine, well, that's just cosine of x, times cotangent, well, that's cosine of x over sine of x. And now we multiply the cosine times that, and now we have here 1 minus sine of it, 1 over, sine of x minus cosine squared of x over sine of x. And this is kind of cool because now look, my denominators are the same, so I don't have to do anything with that. I can just add things up. And I have here 1 minus cosine squared of x all over sine of x. You may be thinking, hey, that looks simpler already. Well, it does. And again, you got to go and remember, hey, what can I look at for that 1 in cosine squared? Is there anything I can do with that? And you got to remember, oh yeah, I have that trig identity of cosine squared x plus sine squared x is equal to 1. So if I subtract cosine from both sides, right, sine squared of x is equal to 1 minus cosine squared of x. The Pythagorean theorem ones. Oh. So I'm going to replace this. Instead of writing 1 minus cosine squared of x, I'm going to write this as sine squared of x over sine of x. And I can cancel out here. I got two sines, sine squared times sine, sine times sine on top, just a sine on the bottom. So that goes away with all that. And I'm left with sine of x. Wow. You started with this messy junk, and you end up with something nice and sweet as sine of x. All right. So now we get to the complicated ones. All right. Okie dokie. So I'm going to employ or do the same thing that I started with, as that is putting everything in terms of sine and cosine. And most of it already is, but here we go. So here I have cosine of x times cosine of x over sine of x. Oops, wrong one. Sorry, tangent is sine of x over cosine of x minus sine of x times cosine squared of x. We see something nice has happened here. Cosine of x times this. Hey, that cosine of x cancels with that. I'm just left with sine of x minus sine of x times cosine squared of x. Which brings us to our next trick. Our next trick is, hey, sometimes we can factor some things. And our next trick, so if I factor out a sine of x, I can go ahead and write this out as 1 minus cosine squared of x. And what do I get? All right, so you may be thinking, hey, we got something close to that whole sine squared of x. I think you're right. Remember, that's just from like last time. Subtract cosine squared both sides, right? So this is sine of x all over, that's going to be sine squared of x, which is then equal to just sine cubed of x. Wow, how cool is that? That wasn't too bad. And so we go take a look. because we can do that algebraically and now graphically. Wow, you got this big giant mess here. After we clean it all up, it's just sine cubed. Bullet. Trig identities are great. All right. So here we go. Next one. Next one is I want to simplify this. Well, what's that 90 doing there? If I take a look at, I have something up there that tells me about this. Is cosine, but it doesn't have this 90 minus something minus x. Okay, so this was our cofunction identities. So if I go and take a look over there, cofunction identities, that means that, hey, they said that cosine of pi over 2 minus x is equal to sine of x. Hey, 90 degrees is really just pi over 2. That's the same business. So when I rewrite this, I can rewrite this as cosine squared of sine of x, cosine squared x, sine of x, minus, well, sine of x. And then what can I go ahead and do? My next step? Hey, I think I can factor something. So sine of x can get factored out. And I'm left with here of cosine squared of x minus 1. And you're going to go, oh, I know this. This right here, sine squared of x. That's what it's going to be. But I'm going to tell you to hold off. And let's reevaluate. Sine squared x plus cosine squared of x equals 1. It's not going to quite work. But what I can do is I can, hey, if I subtract the 1 over sine squared x plus a cosine squared of x minus a 1 is equal to 0. Hey, this matches up with this. So if I just get rid of that sine squared, subtract it, now I have cosine squared of x minus 1 is equal to a negative sine squared of x. That's easy enough for me to do. So then when I go ahead and plug in here, now I have sine of x. This is equal to a negative sine squared of x. Multiply the two, negative sine cubed of x. And there's my answer. Pretty cool, right? All right, last four, last page. And these four get brutal. So if you need a little psych yourself up, jump up and down. You can do this. Not gonna lie, that looks ugly, right? And so what we're gonna see here is what we want is they say simplify. Great. How? They don't have common denominators. I can't add those together. But we can get some common denominators. And what the next trick I'm going to employ is something that's called, I can multiply anything by a special one. And I get to choose that one. You know what one I'm going to choose? It's just like doing a common denominator. I'm going to multiply by the opposite's denominator, my special one. So when I come over here, I multiply by 1 plus a secant x on this side over 1 plus a secant x times secant x over 1 minus secant x minus secant x over 1 plus secant x. And what am I going to multiply on this side? The other denominator. This way I end up with a common denominator. So this will be 1 minus secant x over 1 minus secant x. Because if I multiply by 1 on each side, it's not going to change my value. It's just going to make things different. So, what you should recognize from Algebra 2 is 1 plus a secant x times 1 minus a secant x is a difference of two squares. Okay, it's your unfoiling of that. So when I multiply the two, my common denominator for the whole business is going to be 1 minus secant squared of x. And I go ahead and I'm going to multiply this. Secant times 1 is secant x. Secant times secant x is secant squared of x. A negative secant times 1 is a negative secant x. A negative secant times a negative secant is a positive secant squared x. And as you can see, some things can cancel out. I'm left with the minus the secant x goes away. That goes away. And what I'm left with is equal to 2 secant squared x's over 1 minus a secant squared x. Well, zippity-doo-dah. Well, what can I do now? I go and look at my identities again. I go, well, do I have anything there that has a 1 and a secant squared? And this is where you go, yeah, I've got something in there. I've got, you know, back in my Pythagorean identities, I have tangent squared theta plus 1 is equal to secant squared theta. And this is going to be one of those things where I subtract the secant squared from both sides, subtract the tangent squared from both sides. I get 1 minus secant squared theta is equal to a negative tangent squared theta. I substitute back in. I think I'm getting closer to something. This is looking good. Secant squared x over a negative tangent squared theta. Okay, that's good. But you know me, I don't like fractions too much. We don't like fractions. Fractions are one of those F words we hate. So I can go ahead and multiply. Instead of changing this into a division problem, I'm going to make this a multiply problem. So the 2 secant squared stays the same. 2 secant squared x. So if I times the reciprocal of the bottom. The reciprocal of the bottom. Oh, what is the reciprocal identity for tangent? Well, the reciprocal one, if I do the reciprocal, is cotangent. So times a negative cotangent of theta. Oh, okay. So then I come over here and say, well, the last thing we can do is put everything in terms of sine and cosine. It's a little bit simpler. It's 2, 1 over cosine squared times, forgot about the squared part over here, times, well, cotangent, well, that's cosine over, oops, that's what x's, I got x's and thetas all mixed up. There should be x's here. Okay, cosine squared, sine squared of x, cosine squared x, hey, those go away. Now I'm left with 2 times 1 over sine squared of x, but 1 over sine squared of x is really just cosecant, so I can say this is 2 cosecant squared of x. Whoa! I did it! Look at all that beautiful work. Wow. That's a lot. But I get this big giant mess to look something so nice and cozy as this. And I know that's a lot of math tricks. You're wondering, how do I possibly even begin to do those? And the only thing I can tell you guys is practice. Seeing it over and over and over again is what's going to help you guys out. Okay? So, that being said, let's do another one. Simplify. Okay? Again, I've got some issues. My big issues is that I don't have a common denominator asking me to put this, so I'm going to make a common denominator. Same thing that I did before. So this is 1 plus a cosine of x over 1 plus a cosine of x times the 1 plus cosine of x that we have here over sine of x plus sine of x over 1 plus cosine of x times my special 1. And my special 1 again is the denominator, made of the denominator of the other one. Sine x over sine x. So one of the things that you need to memorize or need to know, not a trick you need to know, is that usually on numerators, you're going to multiply things out. And on denominators, you try and just keep them separated. Okay? So on numerators, I am going to multiply this. 1 plus cosine x times 1 plus cosine x. Alright, so that's going to be 1 plus, again, foiling, right? First, inner, outer, last. 2 cosines of x plus a cosine squared of x. I did that rather fast in the effort of saving space. Right? First, outer, okay, inner, lasts. Okay? Cosine squared of x. Let's see here. Plus sine times sine. Sine squared of x. All over. And I'm going to keep this separate. 1 plus cosine of x times sine of x. And you should hopefully see something that's kind of cool here. This right here, cosine squared plus sine squared, that all just equals 1. So I have that 1 plus the 1 over here gets me a 2 plus 2 cosine of x all over 1 plus cosine of x times sine of x. And what do I do from here? Well, peanut butter. The F word we also like, factor. So I can do that here. Take out a 2. It's 2 times 1 plus cosine of x all over. Hey, look at that. 1 plus cosine of x sine of x. What happened? This can now go away. I'm left with 2 over sine of x. Well, 1 over sine of x is just the same thing as cosecant x. So that's 2 cosecant of x. Whew. It's a long trip. That big giant mess is this right here. Alright, and at this point, you're probably trying to shoot me going, Mister, I don't think I can take any more. Alright, and normally I would be like, I can see that. Alright, but we got one more thing to do, 2 more problems to go, and these go a little bit faster. Okay, those are the 2 hard ones. Let's do it. Let's get this done. And again, hopefully you going over these again and again will help you out. So here we go. Rewrite that as an expression that does not involve fractions. All of a sudden you go, hey, 1 plus the tangent squared x. Hey, wait a second. 1 plus tangent squared, that's got to be some type of identity up there with those Pythagorean theorems. Those ones and tangent stuff gets in there. So I looked that up. You betcha it is. Okay, so that's where I had that whole 1 plus tangent squared of x is equal to the secant squared of x. So I can replace that whole top, and now I have secant squared of x over cosecant squared of x, which again, I don't like fractions, so we're going to go, hey, this is secant squared of x, and I go, well, what's times the reciprocal of the denominator? Well, what's the reciprocal of cosecant? Well, that's just sine squared of x. And we go, hey, I want to keep everything in terms of sine and cosine. So again, secant squared is the same thing as saying 1 over cosine squared of x times sine squared of x. So I end up with sine squared over cosine squared, which is equal to tangent squared of x. Woo! All right. Again, We're almost there. Last one coming up. All the same tricks, just trying to see them many times. This last one here, they give you a multiple choice, but I'm going to do it for you. We're going to work it out together. All right. Again, I got this 1 plus a cosine x. I don't know what's going on there. Sine squared. How can I possibly deal with this? And this is where, again, I can be a little bit tricky. Is that I can say, hey, sine squared of x. I can write that as, remember we've been doing this the whole time, is equal to 1 minus cosine squared of x. Okay, well I can do that. This is looking somewhat promising because sine squared of x over 1 plus cosine of x. Well, what is 1 minus cosine squared of x? And this again is where you got to go back to algebra 2 and realize, hey, this is a difference of two squares. This can be equal to 1 minus cosine of x times 1 plus cosine of x. All over 1 plus cosine of x. Hey, look at this. I can cancel this out. I cancel this out. And what am I left with? 1 minus cosine of x. There's my answer. C is this. All right, guys, we're done. That's it. I hope you can do this. My suggestion to you is to watch these as many times as you can. I know it sounds, but seeing them over and over again will help you. All right, doing the practice will help you. We will get through this together. We'll see you later, guys. Bye.